Let's talk about an algebraic way for solving a system of equations. We've already looked at how to solve a system of equations graphically, where you would take each equation, put it into slope-intercept form by solving for y, then you graph those equations and find their point of intersection. That method is a little bit slow. It's very visual, which is nice. It really shows the concept. But especially if your slopes are fractional amounts or your y-intercept are fractional amounts, that can be a bit tricky. And what if the answer involves coordinates that are not whole numbers or integers? It's going to be very tricky to read that off of a grid and be able to tell exactly what fraction that is. So instead, an algebraic approach would be more solid. It will make sure that we can get that answer every time, regardless of how messy some of the fractions might be in it. To solve a system by substitution, what you do is you choose one of the equations and you solve it for one of the variables. It doesn't matter which equation and it doesn't matter which variable. However, you're going to make your life a lot easier by being smart and choosing the right equation and the right variable. Choose the equation and the variable that is easiest to solve for. That will give you an expression that is equal to that variable, and you will substitute that expression into the other equation for that variable. That will give you a new equation that only has one variable in it. Then you solve that new equation. Finally, you take that answer and plug it back into your substitution equation that you had up above and use that to solve for the first variable. This course make a lot more sense with an example. So let's say we have the system where the opposite of x plus y is equal to -1 and 2x minus 13y is equal to 4. If I look at that system there, hopefully it's pretty apparent that y in the first equation is the easiest variable to solve for. Because if I have the opposite of x, or negative x, plus y is equal to -1, all I have to do to solve that is to add x to both sides. So adding x to both sides very quickly gets me that y is equal to x minus 1. So now what that is saying is, anywhere that I see a y, I could instead replace it with an x minus 1. So I come to the second equation, and wherever I see y, I can instead replace it with the expression x minus 1. You definitely want to do that by using parentheses. So now I get 2x minus 13 times the quantity x minus 1 is equal to 4. And now I have one equation with only one variable. This is a very simple linear equation, so we just need to be able to solve that. First thing you want to make sure that you understand and know how to do is to distribute, because we've got to make that our first thing, which is to distribute this minus 13. You could really think of that as plus a negative 13. I do not combine the 2x with anything yet. I need to distribute that minus 13 because it says minus 13 times x minus 1. We know the distributive property. We're going to distribute that. So I get a 2x, and then a minus 13 times x is minus 13x. But then a minus 13 times a minus 1, a negative 1, is plus 13. So there's my first step, distribute with that expression. That's almost always going to be your first step with this part of the process. Then you're going to combine like terms. I see that I've got a 2x and a minus 13x that are being subtracted, so those are like terms. It gives me negative 11x plus 13 is equal to 4. So then I will go in and very simply subtract 13 from both sides. So I'll subtract 13 from both sides, and that will give me negative 11x on this side, and on the other side it will give me negative 9. So then I divide by negative 11. You need to cancel the negative there as well. So you divide by negative 11, and that gives you that x is equal to, well, negative divided by negative is positive, so I get a positive 9/11. You are not going to want to punch that out and get a decimal because it is a repeating decimal that goes on forever and ever, and you cannot really write it correctly and usably as a decimal. We're simply going to keep that fraction. So now I have figured out what x is equal to, but I have to go figure out what the y is equal to. Let me get this moved over here better. So all I do there then, once I have x, is I take my substitution equation. This equation right here, where you substituted for y, you're going to take that and you're going to plug this x in to that equation there. So that's going to give me that y equals, well, x is 9/11 minus 1. Well, got to know a little bit of fractions here. 1 is 11/11. I need to get a common denominator in order to add those fractions. So then I get 9 minus 11, which is negative 2. You add or subtract the numerators, and you keep the 1 denominator, so negative 2/11. Therefore, my point of intersection, or what's called my solution to the system of equations, is 9/11, comma, negative 2/11. And that is definitely not a point of intersection we would have seen very easily if we had done this by graphing. So this is a great method for finding those trickier points of intersection. Take one of your equations, solve it for one of the variables, whichever one is the easiest. Take the expression you get and plug it into the other equation, substitute it into the other equation in place of that variable. Solve the resulting equation for the one variable you have left, and then take that and plug it back into your substitution equation to get the second variable. So let's look at another example. I have 3x minus 6y is equal to 12, and I have a second equation of x plus 4y equals negative 6. I want to choose one of these equations and solve it for one variable. Generally speaking, if you have a variable whose coefficient is 1, remember that we can always think of this as having a 1 times that, so that's a 1 times x. That's what I mean when I say a coefficient of 1, a variable just by itself, so to speak. If you have that in one of your equations, that is definitely going to be your easiest equation and your easiest variable to solve for. So x plus 4y equals negative 6. I'm going to take that and subtract 4y from both sides. The negative 4y and the negative 6 are not like terms. They do not combine at all. So I simply get x equals, you could put negative 6 minus 4y, or you can put negative 4y minus 6. I like to keep my variable expression in the front of that. Now I'm going to take that expression that I found. I'm going to take that expression and I'm going to plug it into the other equation in place of, not y, but in place of x. So that will give me 3 times the quantity, negative 4y minus 6, and then minus 6y is equal to 12. Distributing, like I said, that's almost always what's going to end up happening, is your first step after substituting is to distribute. 3 times negative 4y is negative 12y. 3 times negative 6 is negative 18. I get minus 6y is equal to 12. Then I'm going to combine my like terms. I've got a y term here and a y term here. So I'm going to combine those. Negative 12 minus 6 is negative 18. So I get negative 18y minus 18 is equal to 12. Then I will add 18 to both sides. By the way, this is not the only approach or the only set of steps. You can do other steps first. That's the beautiful thing as you move up in algebra. You learn enough skills that you learn how to put them together in different ways when you're playing the game. But this is a pretty straightforward way to make sure that you're always sort of doing the same thing every time if you don't have those skills down quite as solidly. This side's going to give me a negative 18y, and then on the other side I'm going to get 30. So then I divide both sides by negative 18. Negative 18. And I get that y equals, a positive divided by a negative is negative, so negative 30/18. However, you should immediately be looking there and seeing if you can do some simplifying. Both of these divide by 6. If I divide the numerator by 6, I get 5. If I divide the denominator by 6, I get 3. So my reduced final answer for y is negative 5/3. Now I take that expression or that answer, and I substitute it back into my equation for x. So x is equal to negative 4 times negative 5/3 minus 6. Yep, we're going to have a little bit of fraction work to do here. That's really negative 4 over 1 times negative 5/3 minus 6. So that's negative times negative is positive, so positive 20/3. So then I got to convert 6 into thirds. 6 is 18/3, because of course 18 divided by 3 is 6. And that gives me 2/3 when I add the numerators or subtract the numerators. So now I get that my answer, I love this little symbol therefore. It's a shortcut. It tells somebody, hey reader, here's where my answer is. So it's very nice. And so x was 2/3 when we were done, and negative 5/3 was my y coordinate. There's my solution. Again, probably not something I would have seen easily if I tried to do this by graphing, but pretty solid set of algebra steps will get me there. Don't forget that the x coordinate always comes first and then the y. But over here, you don't have to solve for y first. You solve first for whichever variable is easiest to get. The easiest variable to solve for in the equation that's easy to do that with. That's going to make things much better for this substitution method.